I'm Sue Erich, and I study carbon in soils. We know there's a lot of carbon in the atmosphere and carbon in the ocean and carbon in every living thing, but a lot of people don't realize there's a lot of carbon in soils as well. Soils contain the largest pool of carbon on Earth, and therefore it's important what happens to that carbon. The more carbon that gets stored in the soil, the less that goes into the atmosphere as carbon dioxide and methane. And storing carbon in soil may help slow down climate change for that reason. So how do we store carbon in soils? When compost is mixed with soil and broken down, it may increase aggregation, which is the formation of clumps which hold water and benefit plants. To study how compost decomposes or breaks down to carbon dioxide, we've set up a number of small jars containing a mix of soil and compost. We're testing 8 different composts, 4 of them produced commercially in Maine. After the compost and soils are mixed together, we put the samples in the incubator, and this is where we hold them at a constant temperature for about 4 months, and we sample every few weeks. The jars on top we use to measure aggregates or soil clumps and also microbial biomass. The jars on the bottom we use to measure carbon dioxide as the material decomposes. What I'm doing now is an acid-base titration, and titrations allow us to measure how much carbon dioxide is present in soil as carbonic acid. In cool, humid climates like Maine, there are a couple of challenges for potato producers: low soil quality and many soil-borne diseases. I recently participated in a 3-year field study where we looked at the effects of compost in conventional potato production and high organic matter systems and its effect on plant health and soil quality. The results of this laboratory work will help us understand the results of our field study, both how quickly compost breaks down in soils and whether it promotes the formation of aggregates, which can help store carbon in soils.